Now, what is backward propagation? We just saw the forward propagation. Now we are going to talk about the backward propagation. The movement from the right to the left in the opposite direction is what we call forward propagation. But let me give you a simple definition here. We can see here that the backward process of a neural network towards the left side is called backward propagation, where a process starts from output layer to the dense layer along with the update of weights and then bias and then finally to input. It's very much clear from its name. Backward propagation means backward movement in the opposite direction. So the backward process of a neural network towards left side from right to the left is called backward propagation, where the process starts from output layer. The starting point will be the output layer and then to the dense layer along with the update of weights, update of random values of the weights and bias, and then finally to the input. This opposite process is what we call backward propagation in the artificial neural network. But let me show you here graphically. I'm going to show you graphically that how backward propagation takes place. It is just the opposite direction of the artificial neural network model. Look, we saw the forward propagation process where we were going from the left to the right in the positive side. We were moving forwardly, but now in the backward propagation we are moving in the opposite direction, from the right to the left in the opposite direction. So we are moving from positive towards the negative side. Therefore the starting point will be the output. If you remember, in the forward process the starting point was the input and then the hidden layer and then the output. But here the starting point is the output, then the hidden layer and then the input layer. This is the backward propagation. Now, why we need backward propagation? We need forward and backward propagation because we do optimization process. Sometimes in the model we need optimization process. We need to update these random values of the weights and the bias. Why we need the updates of these values? We need the updates of these values to get the accurate value here. But when and where this propagation takes place in the model? It is during the training process. If you train the model and you want to get the update. In the deep learning we have epochs. What is the epochs? A single epoch is the cycle of a complete forward propagation and then the backward propagation. If a forward and backward propagation completes, this one cycle is what we call the epochs. We're going to see in the Python language what is epochs. Forward and backward, forward and backward, forward and backward. With the same time, we update the random values of the weights, random values of the bias, random values again of the weight, and then random values of the bias. So at one point, at one stage, we reach to the point where we get the accurate output. So these values for the weight and for the bias is not our choice. It is the choice of the model. It is the random choice of the neural network model. Neural network model selects these values randomly, and then during forward and backward propagation it updates these values again randomly. It is in the control of the model. It is not in our control. It is in the control of the model. So after many epochs, after many forward and backward propagation, at one stage we got the desired output. So therefore forward and backward propagation is very important. It is the operation process of the artificial neural network model. I hope the point is clear by now. Now when you look to this model, my desired input is 2. I want to predict 2 in the output. I just want to pass 2 here. I want to predict 2 as an output here in this model. So what I will do, the process will go forward and backward, forward and backward. The process will select random values for the weights. These are all the random values for the weight and the bias. So after complete process, we got 0.58. After the final activation function, we got 0.58. Now, the output has to be 2. We are trying to predict 2 as an output. Now, what the model will do, it is an auto system. The model will again do optimization process. It will update randomly all the weights values and all the bias values during the backward propagation and the forward propagation. Now let's go for the second try here, where we need to update the random values of the weight and the bias. So when you do all the mathematics, at the end you will get approximately 2. That's what we were trying to achieve. Now look, when you compare the weights and the bias values with the first try, if you remember with the previous first try, these values are different. Previously we had negative 0.3, but this time we have negative 0.1. Previously we had 1.2, but this time we have 1.9. Similarly, the other weights values and bias values. So if you remember, in the first try we got 0.58. Our expected output must be 2. We need 2 as an output. Remember, I'm passing 2 as an input to this model, and I expect this model to predict 2 as an output. That's what I'm trying. I just want 2 as an output, not 1. So what happens, the model do forward and backward propagations. We know that what is forward propagation and what is backward propagation. Forward propagation is the forward movement of the neural network, or the forward process of the neural network from input to the hidden layer and then from hidden to the output layer. The backward propagation is the other way around. It is in the opposite direction, from the output to the hidden layer and then from the hidden to the input layer. So during backward propagation, the model automatically updates the weights and the bias values accordingly. If you remember, last time we got 0.58. Now the model will do analysis that with the first try I didn't get the desired output. Then it goes backward propagations. During the backward propagations, the model updates the weights and the bias values, and then do forward propagation to check that whether the output is correct or not. If still the output is not what we were trying to achieve, again the backward propagation will take place to update the values of weights and the bias. So it is a forward and backward propagation, forward and then backward, forward and then backward. A complete cycle of forward and then backward propagation is called epoch. One forward and then one backward propagation cycle equals to epoch. Don't worry, we're going to do epochs. We will check epochs in the Python language when we were trying to do artificial neural network project in the Python language. So epochs means try again and again. Now look at here, it doesn't mean that you will get your desired output with the 2 tries, means with the 2 epochs. No, it may be 50, it may be 100, it may be 1000. It depends on the model of the neural network. The more complex is the model, the more epochs you will need to train the model and then expect the desired output. So it depends on the model. So some models are complex, they have a lot of epochs, and then we divide the epochs into different batches. But some neural networks are simple, so we need few epochs to train the model and then expect the output. So these epochs is actually the forward and backward propagation. As I told you, these random values of the weights and the bias is the selection of the model by itself. It's not something that we provide. These are the values, these are the random values which are randomly picked by the model at the initial stage. And then do all the mathematics here. We already know that how we do the summation. The summation takes place here, and then we have the activation function. After summation, the activation function decides that whether I should fire this neuron or not. If it allows, if the activation function allows the neuron, and then we go forward to the output neuron. I repeat this thing. Look, when you go for the hidden layer for this neuron, adjacent to this neuron we have 2 neurons, 1 and 2. Therefore, I have 2 summation here, plus bias. Similarly, for this neuron, we have 2 neurons in the opposite side. So I'm going to do 2 times the summation process and then the summation of the bias. Similarly, when you go for the third neuron, we have 2 adjacent neurons. So you have to do summation 2 times plus the weight, plus the bias value. Now, once the activation function allows this neuron to be fired, then we move forward to the output neurons, to the output section, to the output layer. So adjacent to this neuron, we have 3 neurons here, 3 neurons. Therefore, we have 3 times the summation process, 2 times 0.4 plus 3.91 times 0.5 plus 2.9 times 0.3 plus 2.115. This is the bias value. When you do addition, when you do all the summation, you will get 6.02. And then again we have the activation function in the output layer. After the summation, once you complete the summation, then the next job is the activation function. The activation function will decide that whether I should pass the information to the output terminal or not. So after applying the activation function here, suppose I randomly pick 8. So 8 minus f of x. What is f of x? F of x is 6.02, which is the summation result of this expression. Therefore, I can write 8 minus f of x equals to 8 minus 6.02 equals to 1.98, which approximately equals to 2. Therefore, we got the expected output, what we were trying to achieve as an output. So again and again the model do forward and backward propagations, and each time it updates the weights and the bias values. Now the question is that why the model updates the weights and the bias values. It updates the weights and the bias values accordingly to adjust the desired output, which we got here 1.98. It is not necessary that you must get 2, exactly 2 in the output. You can take the approximate value like 1.98. It approximately equals to 2. Now when you look to the neurons in the hidden layer, adjacent to all these neurons, we have total 2 neurons. These are the adjacent number of neurons. So therefore, for each cell, you have to do summation 2 times. This one and this one plus the bias value. Similarly, for this neuron, do 2 summation because we have 2 adjacent neurons. So this one and this one plus bias value. Similarly, for the third one, do 2 summation and then plus the bias value. Once you do with the first phase, in the second phase, you have to repeat exactly the same process. But don't forget, you have to look to the adjacent neurons, the adjacent number of neurons. For example, to this one, you have to pick the adjacent neurons on the left side. On the left side, the adjacent neurons are these. So for the output layer, the number of adjacent neurons are 3. Therefore, we need 3 times the summation process plus the bias value. Don't forget the bias value. So that's the whole phenomena of the neural network. That's how neural network model works. This is the operations of artificial neural network model. Forward propagation, forward and backward. Try again and again to get the expected output. I hope it is clear by now.